If you have a long mill CNC router, then one thing you want to make sure you do periodically is maintain it. In this video, I'm going to show you exactly how to maintain your long mill CNC router. Let's go. idcwoodcraft.com. Hello, my CNC brother or sister. I'm Garrett with IDC Woodcraft, the company that you get your CNC router bits from. In this video, I am going to walk you through a deep dive maintenance routine that you need to do on your long mill MK1, MK2 CNC router so that you make sure that that machine runs right. Darn it. Hello, my CNC brother or sister. I'm Garrett with IDC Woodcraft, the company that you get your CNC router bits from. In this video, I'm going to walk through a deep dive maintenance of the long mill CNC router. If you have a long mill, then you want to make sure that you maintain it periodically. And sometimes you need to do a really deep dive into the machine to get all that sawdust out, lubricate things, and that's exactly what we're going to do in this video. We are going to tear this long mill apart, and this one I'm going to take the trim router off that I had on it, and I'm going to install this spindle. And we'll talk to you about the spindle in this video. But let's get into your long mill so you know exactly how to maintain your machine, get it all cleaned up, tune it up, and make it run good for the next cycle until you maintain it again. So let's go. The first thing you want to do is make sure you get your router bit out of the machine. We don't need it, and we're going to be taking things apart, so we simply don't want this router bit to be floating around, being dropped or something like that. If I can ever get my wrenches on there, and I already had it loose, so we were okay. And then we want to make sure that we get all the debris off the table, put everything where it belongs, and then what you want to do is clean your entire machine before you even start your service program. I mean, you can After you get your machine cleaned up and get all the debris off the table and out of your way, the next thing you want to do is get the machine in the position that you want it to be in so that you can maintain it, do the service as easiest as possible. So in this case, with the long mill MK2, what I'm going to do is move the Z carriage all the way to the end of the lead screw, because I'm going to take the lead screw out, and I wanted to unscrew it as little as possible because I could just spin and spin and spin. And the other thing I'm going to do is move the gantry all the way to the back of the machine for the same reason. I'm going to bring the lead screws out the front. Now, this is a point that I want you to keep in mind. Think ahead of time of what you may remove from your machine and the ease at which you can remove them. I would normally bring the gantry to the front to take the lead screws out the back, but I can't because the wall is in the way. So the lead screw is going to come off the front. So I'm going to bring my Z carriage all the way over to the end of the gantry, and then I'll move the gantry all the way to the back of the machine. You want to unplug the power to the machine and the control cable that's running to your laptop if you have one, and then you can start servicing the equipment. Now, the first thing you ever want to do before you even start servicing your machine is determine what components you're going to replace and have them ordered and at the ready. As you can see here, I've got all my tooling laid out. I may need a couple other things, but I've got my tools and my replacement components that I know that I need to replace. So the first thing I'm going to do now is just to start disassembling the elements of the machine so that I can clean and lubricate stuff. And we'll talk about that as we move along. As you can see right here, I've got a power cord that's running through my drag chain here. And I've got another power cord that's going to this particular Makita that's hanging on the outside. And the reason is because Makitas burn out and they're noisy. And I'm frankly tired of the noise. Spindles are much better. And so I've got a spindle from PWN CNC, which is basically a plug and play. If you're thinking about upgrading your CNC router to a spindle, which I do recommend, then I will put a link down below in this video to this company, PWN CNC. The benefit of their spindles kits is that they are plug and play. You don't have to buy something and try to figure out how to wire it up. They've already got it set up for you for Long Mill, Onefinity, Shapeoko, Millwright, and other benchtop CNC routers. So remember to take a look at the link down below. Okay. One of the other things you want to do before you start is make sure you've got a surface where you can put your components that you are going to be working with and keep things organized. So I'm going to use my table saw with a piece of cardboard, and this is going to be my parts station. So I'm going to be taking the lead screw off of every part of the CNC router. Now, if you have a belt drive, it's going to be a little bit different, but if you have a ball screw, you can't necessarily take the bearing off of the component that's moving the gantry back and forth because you can lose ball bearings. So if you have a CNC router that has a ball screw for the drive system, one of the things you don't want to do is take that bearing assembly off of the ball screw because you can lose the ball bearings. When we have a lead screw, we got a coupler. One of the first things we want to do is loosen the coupler. Now, to make note, this is one of the components that I've seen occasionally on CNC routers where when you've assembled it, this is actually not tightened enough. The screw isn't. So you always want to make sure your coupler is tight. And this is just part of why we're doing what we're doing. So I'm going to work that screw out and loosen that up. And we'll just double check this coupler that's attached to the motor shaft because I don't need to take that one off. And that one's still on nice and tight. So now we've got this side loosened up. I'm going to loosen the couplers for everything so I can start pulling these lead screws out. Now I've got my Y couplers removed, and now I can move the gantry by hand. And if you can look on the front here, my lead screws are coming out. And all I'm going to do is just manually unscrew the lead screw from the anti-backlash nut that's in there. And this is exactly why I moved it all the way back, so it doesn't take much for me to unscrew it. Otherwise, I'd be unscrewing it all the way down through the nut, through the full length of the lead screw. As I'm removing the lead screw from the long mill, it has this bearing here that seats down in this hole here, but it's part of the assembly. So when I take this lead screw out, I'm making sure that I'm taking this bearing with it so I don't lose the position of the bearing, how it's oriented, because you can see it's got a little lip on there. We want that lip to remain in its proper orientation. Loosen and remove the lead screw on the gantry. Again, we're going to check the components that I don't need to take off. I want to make sure they're secured. So this coupler is connected to the motor shaft. I'm not going to take the coupler off of there. So we're simply going to make sure that that's tight. If I can get it into the keyhole. And there we are in good shape. I could feel a little bit. So that's one thing we want to check on that, is to make sure that those things are set up right. I left myself with a little bit of a problem, is I have the gantry or the Z carriage all the way in the other way, which means I'd have to screw it all the way down. So what I'm going to do is move the Z carriage all the way back to this side so I can unscrew it. So I'm going to put the power back on the machine briefly, and then we'll move it over, and then I'll unplug the machine again. Come on, spin off. Make sure you put your stuff on your station and keep it organized. Now, because I'm upgrading my long mill MK2 to a spindle, I have all my wires running through this drag chain here, but since we're going to have some added wires going through this, I have to have a larger drag chain. So I got to pull all the wires out to replace this drag chain with this wider drag chain here. And so these are things that there are a couple things that you're going to have to get if you're going to upgrade to a spindle. I'll link everything down below, and I'll put everything on a PDF so you can just print it out and get everything you need to get for your spindle upgrade that you'll do with your benchtop CNC router. Come on, baby. Trying to do it without moving the chain too much. Okay, I'll move it this way. Yeah, there we go. As I'm taking all these wires off, one of the things you want to make sure is that you are very clear where these wires are coming from, especially if you're doing what I'm doing, because we're going to rerun these wires. So I'm going to be making sure my connectors are all marked properly. This one I just disconnected from the Z motor, and so I'm going to write on it Z. One of the little habits I've gotten into in my days when I did maintenance on machines for production, in the factories that I worked in long ago, was when I took components off, I didn't always take them over to a station and set them up in an organized way. What I like to do is, especially when I'm working with screws, if you look down here at this drag chain, I've got 2 screws here. I've taken the drag chain off of this. It's going to go in the trash, or I'll give it to somebody and replace the drag chain. But I don't want to take this part off because I want these screws in this bracket the entire time, because I don't want to have to guess which screw is going to go where if I have them over on my station. Whenever you can, it's good practice to keep the components actually with the device so you don't have to do any guesswork later on. The nice thing about drag chains is they are meant to be disassembled. Usually you just have to give them a twist. In this case I can't, so I'm going to actually physically twist it away and pivot it out if I can get that to do it. Just like that. That's how you take drag chains apart and make them longer and shorter. Well, the next thing I need to do is take the Z carriage off of the assembly here, and that's the next step. What I want to focus on as we're doing this is you want to make sure all your moving elements are absolutely clean. In the long mill here, we have a couple of components here that we want to replace. Like I said in the beginning, they need to replace my V wheels. They are a wear item. Now, these have lasted about 2.5 years, so they're not that much of a wear item, but they are starting to show some wear. So I'm going to replace them. And you can see as they start to wear like this, there's a little bit of black buildup along the rail here. And so one of the things you'll want to use to clean any kind of debris that's stuck is you want to use Scotch-Brite. Scotch-Brite is non-abrasive, but it will get any of the grime off. And if you need to, you can actually wash things with soap and water when you have a heavy buildup of grease. If you wash things with soap and water, use Dawn, and also you will want to make sure you dry it off completely very quickly. You don't want things to start rusting. So taking the V wheel off, and again I've got loose components. So what I'm going to do is take these components, this is trash now. I'm going to take the screw and I'm going to put it right back in the hole, and I'm just going to put the nut on the other side and leave it hanging loose. That way I don't lose them. Okay, again I put the screws back in place, and now I can take the carriage right off and we can replace all the V wheels on the carriage. We'll take care of that after I do some other things to the machine, because not only do I need to replace the V wheels, but I also need to check these linear bearings as well. I need to check components inside here, and of course we're going to have to get to the back in order to replace the anti-backlash nut. So this is why we want to actually get in there and clean our machine out and sometimes take it apart. You can see I got a lot of sawdust that has gotten into spaces that not only can't we see, but can't clean out. And this sawdust has oil in it as a result of the oil that's inside your bearing. And all these bearings, these rollers, are like that. And you're going to find that on your CNC machine. And even the screws that are holding them down are building up sawdust. So that's why we want to really get into your machine periodically to get things really cleaned up. Just shut everything down, tear it apart as deep as you need to go to get all this debris out of there. So here is the anti-backlash nut, and the screw goes in through that thread, and this little set screw there is what actually spreads it to grab onto the threads. But this threaded part wears out on this occasionally, and so this is one of the things that you always want to have as a backup if you have anti-backlash nuts in your machine. Again, I'm going to put the screws back on the anti-backlash nuts, and I'm not going to throw these away yet because I need to save these screws. I need to save the little nuts on the back side to put my replacements on. We have more sawdust that gets caught up inside areas that we can't see. We got it around the threads there, and we got it inside the anti-backlash nut there. All right. Now, when you're taking components off your machine, if you're going to lay them down and you've got precision surfaces, like I'm going to lay it down on my rail here, you always want to protect it so you don't put dings in it or damage it. Now what we're going to do is we're going to clean all the running surfaces of the long mill, top, bottom, and the two side-to-side rails. And this is where we're going to use the Scotch-Brite to clean things up. And also, if you find nicks, this is the time to get things filed out. So let's pretend we have a nick here. Now this is a flat surface. What you want to do is just take a metal file. Metal files have very fine teeth on them as opposed to wood files that have much more aggressive teeth. And you'll hold it flat, and once you get it flat, you can just run it along like that. Now, if you have a round shaft that you're trying to clean up, what you'll do is take that file flat on it, and as you move the file, you're going to move in a circular motion around that area, that rounded area. At this point, I've got the machine pretty much torn apart and have cleaned a lot of the elements on it, but here is another aspect where sawdust just finds every nook and cranny it can find, and it's going to park in there. And that sawdust is going to act as an abrasive. So that's why we periodically want to deep dive into our CNC routers and just make sure we get all this stuff out. So I'm going to clean all this out, and then we're going to reassemble the gantry with the new roller bearings, and we'll take it from there. Never underestimate the power of compressed air, and never underestimate the power of compressed air. What I mean by that is, the first thing, compressed air will move a lot of dust out of the way really fast, but it can also cause material to be jammed up into little nooks and crannies. And so after you're done blowing off your machine and getting things all wiped down, you really want to get your eyeballs into these places and make sure you don't have any sawdust bound up in areas where there's precision, such as I have bearings right back in there. And so I need to take a look at those bearings and make sure that there's no sawdust that I've jammed up in there. All right, so I got a little bit of dust in there and some old dirty oil on that. All that oil loves sawdust. So that's why we want to get in every one of these things and clean everything out. And finally, we want to make sure that our bearing actually still turns and is not bound up. At this point, we're going to start replacing components, and we're going to start with these two roller bearings on the gantry. Now you notice I haven't taken them off because I didn't need to. I'm going to interchange these things one at a time, and I'm going to clean everything around it, behind it, as I'm changing them. Now you can see this is the new bearing, this is the old one, and you can see that there's definitely wear on that bearing. I've actually let it overwear, so This is what we always want to watch for on these components. And this is why this is a consumable component on the long mill MK2. It's time now to put the gantry back on the machine. And so I am at the front of the machine, and this is where we want to be careful. We're going to slowly set one side down onto the V channel, in this case with the long mill. And now you see I can't get it there, so I'm going to have to pick up and let them come in together. Just very gently set them down to make sure everything just rolls back and forth very nicely. At this point, it's time to put on our V wheels on the bottom so the gantry is properly set. For the V wheels, we have these cam nuts right here. And the cam nut has an offset turn on it relative to the center of the screw. And what that does is it makes the V wheel move up and down, and it'll allow the V wheel to press up against the lower part of the Y rail right over here, and that'll make the gantry hold down properly without any play. So again, we want to make sure we're cleaning things as we move along. We got dirty screws here, we got to get the sawdust off those screws. Cleaning that. On the long mill, always remember that the screw goes in and the little washer goes in behind the screw. We're not going to tighten this down at this point. You can see that this wants to fall backwards, so we always have to be a little careful of that. But once we get one of these V wheels in place, it's not going to fall backwards anymore. So I'm just hand tightening it. I'm going to do that all the way around on the gantry. Now, one thing to be careful of on the long mill as you're putting this together is you want to make sure that the V wheel actually sits on the V. You can see right now I put it in and it's not on the V itself. It's hanging on the outside. So we're going to have to unscrew that again. This is why we don't tighten anything up. We want to double check everything first to make sure we're okay. We're watching to make sure we don't drop out the washer that's behind there when we get that into position. So now we're there, and I've got to get it into the hole. And our V wheel is now set properly, and the washer has fallen out. So I have to take it back off and put it back on. Now we're ready to secure the gantry in a way that it's going to hug the rails. And that's where these cam nuts come into play. So when you come down here, what I'm going to do is on the back side, I'm going to take the screw and I'm just going to snug it down. And then we are going to start to rotate this cam nut. And I'm looking for up and down play on the gantry itself. And what I'm going to do is roll this cam nut around, and as I move it, we got the cam or the V wheel right here, and I'm actually trying to stop that V wheel from turning. And as long as I can stop it from turning just like that, we're too loose, I'm going to snug it up just a little bit more to grab that rail more, and there, now I can't stop it. So that's where we're going to hold that at, and we are going to tighten the screw down on the other side. And this one is set for now. Everything's tight there. And I'm going to double check. Okay, so I can still move it a little bit. So I didn't adjust it quite right. I got to turn it just a little bit more. And I'm going to have to loosen the screw up. This is how we set the V wheel on a long mill. All the V wheels are now attached to the gantry. It's on the Y rails, and I can move this thing back and forth freehand. There's a little bit of resistance here, which is what I want because I want it to break in as it works itself out. When we're all done, we're going to run this through a break-in cycle, which I have a video on, and I will link that video down below. If you have a long mill MK2, MK1, or any CNC router, and you get it, you always want to break it in, run it through a break-in cycle. I'll put a link for that video down below in the description of this video. The next step is we have to install the anti-backlash nuts. Now, the anti-backlash nuts are a wear item on the long mill MK2. This is the only other wear item on it. Now, they have new style anti-backlash nuts. And one thing we have to do is take the nuts out of here that actually mount it to the brackets, and install them into this anti-backlash nut. These are press fitted into the anti-backlash nuts, and the way we're going to knock that out is very straightforward and plain. I'm going to find a surface where I can just set this guy on, and I'm going to use my hammer to knock them out. So these anti-backlash nuts are now knocked out right here, and we're going to reinstall them on these. Now the thing we have to be careful, these are nylon anti-backlash nuts. So the nylon part needs to go facing up when we install these in there. So these are not pressed in, they are fitted in to the hex. So the lead screw is an Acme style thread or a butt twist style thread. That's going to screw into this anti-backlash nut. And when you tighten these screws down, it actually grabs onto it, and it's a much better way to prevent backlash than this style is, because this is a very touchy, just very touchy to set it up properly. Next step is to reinstall the lead screws. But first, there's two things you want to check. Number one is we want to make sure that the lead screw is clean, which it's not. So we're going to clean this up. I mean, it looks nice and shiny, but it's not. And the other thing is this bearing. We just want to double check that the bearing works okay. So we're going to pull it off and simply hold it in our fingers. We're going to pinch onto here. Now see, we got to clean that up. But I'm going to pinch on here and just make sure it rolls smoothly. I don't feel any bumpiness in there or resistance when I'm spinning it, and I don't. So we're good. So what we're going to do is just clean it up, get all the dirt off of it, all the way around. This is an oilless bearing. It's a sealed bearing. This plate right here, that seals the bearing so we don't have to oil it, and that brass plate does the same thing. So we're going to do this to both roller bearings. And then we're going to clean off the lead screws, take a rag, and this is the fun part. I'm just going to go here and turn while I'm squeezing the rag. We can chuck a drill up on the end and spin it with a hand drill, but if we do that, we can scar this. This is an exposed, unused area of the thread, so we actually can do that, but I'm just going to do it manually and do it like this. And you can see I'm already getting it all cleaned up relative to, let's see if I got some dirty spots on there. Got a couple dirty spots in the very end. So we're going to get all that dirt off of there. Let's go ahead and finish that out. And that shines up nicely, doesn't it? We've been diving into this for a little while, but we still have a long way to go. But I just want to say, if you are starting to get understanding of how deep we need to go sometimes into your long mill to make sure it's running right, then give me a thumbs up down below, that little thumbs up button, and maybe a comment of something you see that I maybe could be doing differently, or some other suggestions on some of the things I've already done. Comments always help the YouTube channel. If it's helping you, it's going to help other people. Let's keep going. So now it's time to put the lead screws into the machine on the Y-axis, so on both sides, and screw them into the anti-backlash nuts, and then secure it back to the coupler over here. But there's one more thing we need to take a look at. So you see this bearing, which I pointed out earlier, has a flange on it. So it's a flange type bearing, and we have one on the far end, and we've got one here that's right by the motor for the long mill. And what we want to do is, of course, we've already cleaned it up earlier, but we want to make sure there's no slop in that going back and forth. So what I'm going to do is simply take my finger on the back side and on the front side, and I'm going to push it back and forth to make sure there's no play. If there is, what you want to do is loosen this screw here on the motor shaft and just gently press it against the flange of the bearing so the bearing presses against the wall of the long mill bracket here. We're good on this side. We're going to check the other side real quick, make sure that's good. And there's no movement there. And give it a quick check for dirt. There's a little bit of sawdust in there, but I just want to make sure that there's no sawdust up in there, and I do see some sawdust up in there. So one of the things we want to do is I'm going to take the motors off. We need to check the motor screws anyway to make sure they're holding the motor in place as they should be. In this case, I'm going to just take the motors off, get all that sawdust out of there. You see we've got quite a bit of dirt here, so it's a good thing to check. Just get all that sawdust out of there, out of your equipment. So that means we're going to take the motor off the other side as well. Now I got this little washer here that actually, this is one of those components that you got to be careful of. You need to keep it in here. This is a spacer that's going right in here, and we're going to put this back on. Now I'm going to set this washer aside for the moment. We're not going to tighten the motor down. We're going to leave it loose as we insert the lead screw. But I'm going to do the same thing to the other side of the machine before we tighten things down. Okay, I'm actually... Next step is to take the lead screw, and we are going to run it through. Then I'm going to screw it into the anti-backlash nut, and we're going to screw that through, well, perhaps an inch or so. We went enough that the screw is going to go into this coupler here. The first thing I'm going to do is just make sure that the screw passes into the coupler so everything's in alignment. And I'm going to run that washer in, and then we're going to position it just like that. And we'll run it all the way in to the coupler so it bottoms out. And if you're not sure that it is seated in here, then you're going to have to loosen the brass screw that's on the end, on the other end of this lead screw, and unscrew this nut a little bit, which is something you should probably do anyway. And I know this is seated now, and we're simply going to tighten it up. Couplers, we don't have to over crank it. We want it to be tight, but not over cranked. Couplers hold very well, and that's because it's a whole diameter holding onto a whole diameter. It's one of the strongest clamps that you can get on anything. A round thing clamping on a round thing. So we are in good shape to go. Now we just have to attach the gantry to the anti-backlash nuts, and we'll be ready to run the machine a little bit just to make sure everything's working right, nothing's binding up, and then we'll get to the Z-axis. At this point, the gantry is now secured. I just need to secure this motor, and then what I'm going to do is manually turn the lead screws until the whole gantry butts against the back brackets. Now we want to make sure this bearing seats into this housing here. And I'm just going to push it in, and it is not completely seated, so I'm just going to tap it in. There we go. And we can look at on the side, and we can see that the bearing is seated flush against the leg here. Now we're going to turn that up. Now we're going to use some pliers. I'm going to use it right at the end of the screw, right over here. That is not a needed part of the screw. The anti-backlash nuts come up to about this point, so this is okay to grab onto, and if I nick it, we're going to be all right. We're going to just put a little pressure on that. Make sure it's pulled in tight. And you can see it wants to bounce back, so I am going to force it up like that, and then we're going to tighten it down. At this point, I'm just going to make sure everything's tight. I'm going to move the gantry back and forth, see if I got any wiggle in there. We'll do it on both sides. I feel no play whatsoever, which means we are tight. At this point, I'm just going to drive the whole gantry back to the back of the machine. That means I'm going to power it back up. I've turned the machine on. I've moved the gantry all the way back until it butted up against the back brackets. And now I'm going to just put a very light lubrication on the lead screws. So what I like to use is this very light 3-in-1 oil. And it doesn't have to be heavy. There's going to be spots that I miss. And we're going to do the same on the other side. But before I do that, I'm just going to take now the rag and just run it down and wipe up whatever I can, because I don't want it to drip down on my table. We'll do the same thing on the other side. Wipe up any excess. And now I'm just going to run the machine, the gantry, back and forth a couple times. And then we're going to bring it forward so that I can start working on the Z carriage. I'm going to be upgrading the Longmill MK2 to a spindle. And in order to accommodate the water lines, because I'm using a water-cooled spindle, I have to install new and wider drag chains. So I had to pick 3 of these up from Amazon. If you're upgrading to a spindle, this is one of the things that you're going to need to get. Now, this is the original drag chain. This is the wider version. Now, looking at the original drag chain end piece, there's 2 screws that are in line. But if you look at the new drag chain, it's not set up that way. We got staggered like that. So what I'm going to do is I'm going to set it on there using this hole with this screw. And so I'm going to drill a new hole in the back here so that I can use both screws to secure it down there. So let's take care of that now. I have my drill ready, and I am simply going to guesstimate where that needs to be, and I can always open this up as needed. And before I even do anything further, I'm going to pop open all these gates. Doing this is not so much fun, but snapping them back down is very satisfying after I get the wires laid in. So we can see that this here is the motor for the X drive, and that needs to be exposed, so I know that I have this much too many links on this, so I'm going to have to knock some of these links off. We'll take this link off here. And now it's time to get into the Z carriage, the part of the machine that runs back and forth along the gantry. So the first thing I'm really excited about is this bracket here. I got a new bracket from a company called Pawn CNC, which is the company I got the spindle from that I'm putting on this machine. And you can see the difference in this bracket. So this one comes with a plate. Now you can see that this plate does not fit this one. This is what we're looking at here is the carriage that came off my MK1. This machine that you're looking at right here, this is actually a retrofit kit from the MK1 to the MK2. What I did is I took the 30 by 30 and expanded it to a 30 by 48. If you have the MK1 Longmill CNC router, you know you either got a 30 by 12 or a 30 by 30 machine, and you have probably experienced some limitations in that where you wanted to cut a bigger project but couldn't. Well, Longmill has a retrofit kit for your MK1 12 by 30 or 30 by 30 where you can turn it into a 30 by 48. So I'll link that down below in the description of this video. So if you want to expand your machine, then you can now do that with your MK1 30 by 30 or 12 by 30. What we're going to do now is get into the Z carriage of the machine. I'm going to tear it apart and we're going to clean it up, and then I'm going to put this new holder on. And I want you to really check this out as far as the amount of hold that it's going to do on your spindle or your Makita router or for your spindle that you might be getting for your machine. On the standard long mill bracket, we're holding on to maybe 20 millimeters or a little over 3/4 of an inch. But you get the bracket from Pawn CNC, and now we're holding on to 1.5 inches of material, which will make this whole thing a lot more robust. With this bracket, that you can get a little bit of chatter or flex just because this is a thin bracket. So I absolutely recommend, whether you upgrade to a spindle or not, that you get this bracket from Pawn CNC. I'll link this down below in the description. So let's tear this apart. We're going to take the bracket off. We're going to clean up any debris in there, and we're going to change that anti-backlash nut and put it back together. Mount this on the machine. Get all our plumbing hooked up. The plumbing is, I've got the water-cooled spindle, so I need hoses going to the spindle and everything else I got to take care of. So let's get into this. I'm going to take this bracket off and get it out of my way. And I have to get the right size wrench, which I do. It's a 5mm metric wrench. So we're going to loosen those up and get rid of that puppy. The other thing we're going to be doing too is making sure these linear bearings are in good shape, and we're going to definitely oil everything up here because this is a slide and there are ball bearings that run up and down in that, and they do wear down over time. My years in manufacturing, I have dealt with linear bearings all the time. So we'll see what kind of shape those are in. Those are not generally something you want to replace. You just want to wait until you actually start to see them go bad. And the way you'll see them go bad is you will start to see these red seals start to break apart right up in here. And if you start to see any break apart of these red seals, then it's time to replace those. Don't wait, because bearings will fall out of these things. I've seen one ball bearing cause $10,000 worth of damage. All right, so we got that out of there. Now I'm going to hold on to all this hardware. We're just going to screw it right back into the plate for now and set this all aside. Again, this is a habit you should get into whenever you're taking screws out. Always put them back. Just to hold them where they belong. Even though I'm not going to use this plate, at least I've got them secured in something large, so if it falls on the floor, I won't lose the screw. The next thing I'm going to do is loosen up and remove this, this anti-backlash nut that is going up and down in the Z carriage right there. And we'll do that by removing these two screws, and then we'll manually loosen it up. So I'm going to drop these screws out. I've really been taking this machine apart down to its core. This machine has not been apart for a very long time like this, ever since I put it together originally. And you see I'm just spinning the whole shaft, and this will come all the way down and off. And I'm really glad that they have upgraded this, because these are a little bit challenging to work with when you're trying to tighten the screw up, the little set screw on there. When you're trying to tighten it up, it's not the best design. So now the Z carriage is free to move. It's no longer locked to the thread. But we want to take a look at this thread too. I want to pull that off. I'm getting a feel for this and how it's moving. It feels a little bit resistant, but it's not feeling like it's really catching anything. But we're going to clean it up. We want to feel along here, along all the runners of this, to see if there's any nicks. And you can just feel that with your finger if there are any nicks. And if there are, then you'll have to get a little stone, a sharpening stone or something, to just gently clean those down to the original ground surface. So far everything's feeling pretty good. If you do feel any kind of nicks along these rails, these linear rails, then that would imply that you're starting to damage the bearing. And that's the point when you want to take a really close look at the bearing itself. Now, as far as maintenance goes on this, on a regular basis, you want to put a little 3-in-1 oil on those linear rails. So maybe once a month if you use your machine a lot, every couple of weeks. If you don't use it that much, once every 3 months or so. So now we're gonna take the screw out, and the way we're gonna do that is we're gonna take this little this gear off here. But we can't just take it off because the belt is tight. So we have to loosen up the motor, slide the motor forward, and then we can take the belt off, and then we can take care of that. Now these screws are actually, that's pretty tight, but this one felt a little bit loose. And this is part of your regular maintenance routine that you want to follow every month or so. You just want to go around and just check all the bolts and make sure they're all in good shape. So we've got all these loosened up. I can now scoot that motor forward, and we'll be able to maybe take the belt off. It won't slide any further forward, so what I'm going to do is I'm going to loosen the set screws here, and I'll slide the 2 splines off. There it is. There's that one. That one. Those felt a little loose. I would want to tighten that up too. So that's part of the regular maintenance. Now that one's in good shape. That's on there nice and snug. And that one is not loosening up. Feels like it might be stripped. There we go. We got it. Now we'll just slide everything off. And we can now slide this screw down. There we go. And again, we got another bearing in here. And you can see there's a lot of dirt built up on it. Sawdust. Not as much. I did blow this off pretty good. So we're going to pull that off and work that out. And then we're going to pull these 2 bearings out, get my rag and clean everything. All that oil, all that dirt. Again, with these bearings, you've got the brass ring. That's sealing the balls inside the ball bearing. So we don't have to worry about that. It's not a bearing that you have to oil, but we do want to check them to hold the, if I remember right, this is called the race, the inside, and this is called the chase on the outside. And we want to hold the race and turn the chase. And this feels very nice, very clean, so that's good. There's no nothing like feeling bumpy or anything in there, so it's running very well. Finally, we're just going to clean up this lead screw here. I can just take my rag, spin it through there, get that dirt off. This is the kind of dirt buildup that you get on these things, and that's not really sawdust. That's more oil, and that's from me lubricating it once in a while. We'll do it there, and this is coming out nice and clean. Just want to check all the other screws and make sure anything that's mounting anything else to whatever is tight. So I'm going to check these 2 screws. That one was loose. Now this is holding the plate here to this bracket right there. And that was a little loose. So any kind of loose screws are going to cause chatter in your projects. So apparently I have not checked this in a while because both of these were fairly loose. And now I want to make sure we're tight here. It's a bigger bolt. Every single screw needs to be checked. That also was quite loose. All right, so we've got that. And then I'm going to check all these screws. Those are the ones that have mounted, that hold the linear rail down. But again, I just want to move this back and forth a little bit. And I'm actually going to put a little oil on it. It feels good, but it feels a little bit tight. We'll put oil on it afterwards, but there is nothing in there that's holding it back, so we're good. So we're just going to check all these screws. We don't want to over tighten it. The smaller the screw, the easier it is to strip screw heads out or strip the wrench. So these don't need to be super tight, but every one of these seems to be just a little bit, it's coming on the verge of being a little bit loose. Good there. We'll do the same thing on the other side. We want even torque everywhere, and when you're done doing that, you want to move this up and down again, make sure everything's running quite nicely. Now, we're not going to worry about these screws at this point, but we will take care of this a little bit later. This is how we're going to set the tram on our machine. So what I mean by tram is you have the work surface of your machine, and then you have your router. And the router is going to move across that, and this work surface should be exactly 90 degrees from the axis of this router. When a machine is out of tram, it's essentially the router or the spindle head is tilted. It can be very slight, but that's out of tram, and that will show up in the cuts on your project. So when everything is said and done, one of the last things we end up doing is tramming the machine to make sure that the axis of the spindle is perpendicular to the work surface or the spoil board of your machine, both in the X direction and in the Y direction. Also, we are going to replace these wheels here, and I need to check this anti-backlash nut. Now you notice this is a much bigger one, and Long Mill's not come out with the new style in this size. Now the reason this one's much bigger is this is to accommodate the retrofit kit for the Long Mill 30x48. If you get the Long Mill 30x48, which is the one I recommend, then you're going to have a bigger anti-backlash nut. If you're in the market for a CNC router and you're really not sure which one you want to get, and you've been trying to figure it out, I've created a video that is a full deep dive review on the Long Mill MK2, and so that will give you a good insight not only into the Long Mill, but it is also intended to educate you about what to look for in CNC routers as you're doing your research. There's a lot of good machines out there, and there are some bad machines, and you really want to know what you're looking for. And one of the things I always stress is the company and the support that it gives you afterwards. A lot of CNC router companies, they sell you the machine and they say goodbye. And sometimes you have problems with CNC routers. It happens once in a while. You want that company to be there for you. That's why I recommend the Long Mill, because they are always there for you. All right, so we are going to come back into this. I got to make sure this anti-backlash nut is tight. So we're going to get to the back of that. We're going to replace the V wheels on this. So there's the two screws for the anti-backlash nut. I'm going to just give that a check. That was a little loose. So all this little bit of looseness that I have on this machine is contributing just a little bit to cuts that are not as good a quality on the machine that I would want to get. So these are all relatively loose here. And let's take a look, see what I got. We don't want to be too tight on this. These are plastic components here. There we go. Wow, I'm surprised. This is one of those things that it's just deep inside the machine and we don't realize. And this is the importance of what we call preventative maintenance. As they say in manufacturing, if you don't schedule the maintenance on your machine will schedule it for you. Always remember that. And it will never schedule it when you want it to. So now we've got that. We're going to replace these two V wheels. So there they are. There's the brand new ones. We're going to loosen these guys up. And where do we want to get to here? We're going to grab our 5mm wrench and our 8mm, 5mm, 8mm, and take everything off. We're going to do one at a time. And I'm going to replace one at a time. So I'm going to do a complete swap. And we're going to be very careful. I don't remember if I have washers. Okay, this is the adjusting screw. And what this does, this is part of your tram. Not only does it help you secure your Z-axis to the gantry, but it also helps you adjust the tram. So we've got that one. I'm going to take this one off. We're going to make sure we're not dirty on where it's mounted. Both sides, we'll clean it up. And now we're going to take that bad one. And there's a washer behind it, and there's a washer in front of it. This is why we're very, very careful doing this stuff. So I'll get back. That didn't want to slide in. There we go. Let's make sure that nice and clean there. Feels clean. We're going to put that washer back on. We're going to bring it back to the plate. The reason the washers are there is so when we tighten everything down, it'll be, it won't grab the race or the chase on the bearing and cause the bearing to stick. So we're going to put that cam nut back in. We're going to just bring things in. We're not going to tighten them. We're just going to bring them hand tight. And now we'll do the same thing to the other side. Clean that one off real quick, and we're going to put another wheel on there, put the washer back on, get our cam screw, cam nut, put everything back together. And we are ready for the next stage of this whole process. Okay. Got a little bit of play there, so I want to loosen this one up. Good. All right. Now I have put the Z carriage back together, cleaned everything up. Now we're going to put the anti-backlash nut on. And the way we want to put that on or orient it is so the screws are facing upward. Again, we're going to have to be careful. We have the nuts that sit in there, these two guys, which I have to pound out here in a minute, and they can just drop right out. So we're going to have to hold this thing in the proper orientation. And first we're going to just knock these nuts out. I'm going to start this. Oops, got my wrench there. I'm going to start this screw on the nut. Yeah, we'll have to come back. So, there we go. There it is. And I just want to check and make sure. I gotta tighten this motor up. This motor is still loose, and that, as I'm turning it, the belt's skipping teeth. One other thing about timing belts, and this is the only place the timing belt is on this machine, but other CNC routers have timing belts driving the entire thing. Timing belts have to be at tension. So if your timing belts on your X axis or your Y axis has a little flop or slop, then you're going to have problems. You usually have that tight enough that when you pluck it, you can hear vibration out of it like a guitar string. And unfortunately, most machine companies that sell their CNC routers with timing belts in those scenarios don't provide the necessary tool you need to tension those belts. And this is why I am not a big proponent of buying a machine that is belt driven. Now, not to say that belts are bad, but if they are not set properly, then you are going to have problems in your cuts. It's going to be inaccurate, and we don't want that. Okay, so we're good there. So now I just want to bring that anti-backlash nut up, and I want to see where it is going to top out at. So the plate's going to top out there, and I want to make sure that the anti-backlash nut is not going to hit anything up here when this plate is maxed out in the Z positive direction. So what I'm doing is I'm looking at the holes where it's mounted at, and I'm looking in here to make sure it's not touching anything. I know that I'm good. I can now assemble that, and I just need to move things to where I can access the hex holes. The nut should be on this side, and you can see if you get in close there, I have this upside down. So I need to back it all the way down and rotate it 180 degrees. So what we've done with the Z carriage, and that's what this assembly is called, is a Z carriage, is I have put everything together, I've tightened everything down, I have checked this lead screw here for any play whatsoever up and down, and there's absolutely nothing coming out of that, which means that's good. I'm checking the tension on my belt here. We are good on the timing belt, and I am just running it up and down. It feels very snug coming up and down. So now we're going to put this plate back on right now by unscrewing all the screws that we safely put there so they didn't get lost. Now we screwed into the bracket itself, and we got the 65 millimeters. I want that to be on the right orientation, so it's going to be like that. You have a choice between two positions, and we're going to choose, we'll go with the higher position. This will give you a little more Z height in the travel of your machine. So I've got to get those holes in a position where I can put the screws in. So we got to just manually drive it down a little bit. And at that point, we have reached the bottom of our travel. So this is why we do this. So I've run into something and I shouldn't be running. Okay, so I just have my V-wheel screw hanging out here. All right, that concerned me for just a minute. That was stopping it, because this should come all the way down to that little screw hanging out there where the bearing itself bumps into it. And now we have full travel. I'm going to back it up a little bit so I can expose the 4 holes. And we would basically just put this on and go with it like that. And once we get all the screws put in, then we will mount it back up on the machine. The Z carriage can now be installed on the gantry. You put the lower V wheels on and get everything adjusted in right. But in my case, I'm not going to do that. This plate right here, I don't want this anymore. I am upgrading my long mill to a spindle. And so I have a different plate that's going to replace this one, and that is this here. This is made by PWN CNC specifically for the long mill. And then I'm going to use this upgrade bracket rather than the original one that came from long mill. You can see how much more meat is in there. So I'm going to replace this. All right, so I'm going to start taking this thing apart, and then we're going to get this plate on there. And the way I'm going to take it apart, I'm going to remove these bolts and these 4 screws that are on the linear bearings here, and simply replace it with this custom component. Now this is available at the PWN website. Now down in the description below, I'm going to link everything that I'm talking about as far as the spindle upgrade goes, so that you don't have to go looking for it. In fact, I'll have a PDF that has everything, so you can just download the PDF, and then you can get everything from there, because the PDF will be linked as well. That will be down in the description, a quick download. All right, we're going to take this thing apart and put this plate on. Now, one of the things that I noticed when I was taking the screws out from the linear bearings, which most CNC routers have, some of those screws were loose. So this is part of the maintenance routine that you want to check. Every single bolt on your CNC router, when you do maintenance, you need to check. Now that I have the linear bearings open and exposed, this is where I can lube this up. It was pretty good before, but I want to make sure I get some good oil on there. So I'm going to just put a drop on here and then run that bearing up and down. And we can see it's kind of, it's not touching all the way there. We'll just make sure we run that bearing all the way around. I can already feel the oil starting to loosen things up. It felt good before, but this is what we need. So I'm just going to put some on my finger and run it all around this. That's the best, easiest way to do this instead of trying to dribble it on. Oh, that made quite a difference. Okay. And then I'm going to wipe off any excess because oil is going to attract sawdust. All right, it's time to put on this plate. Again, this is the backing plate for the spindle mount. The spindle mount will bolt from the front right through here, and PWN is going to send you the hardware that you need to properly mount these, because some of the components that Long Mill has sent or your machine company has sent will not work with the modifications that they've made. In this particular case, these screws that were mounting the original plate to the linear bearing, the washers that are on them I don't need. They're not going to fit inside the holes that PWN has put on their adapter plate unless they modify it. So I'm going to take the washers off of all 8 of these screws and I'm going to drop them in. Now there's a lock washer here that we do want to keep on. So we don't want the flat washer, but we want to keep the lock washer that's on the screw right there. Now I've got all the screws in place on this plate. For any circumstance where you have these linear bearings and you have these screws, what I want you to do is we want to pre-tram the machine. And what tramming means is when the router itself, you have an axis that's going down the center of the router that the tool is spinning around, the CNC router bit, and then you have your work surface. You want that axis to be perpendicular to the work surface. So the tool is spinning and it doesn't cause a cut like that. So to tram your machine, it means to bring it into perpendicularity to the work surface, both side to side and front to back. So that's what we want to just do. And the way I'm doing that here is simply by bringing this all the way down. And I'm simply going to snug all the screws. I'm not going to tighten them all the way. Now, this is one of the things we're just going to have to remember, that we have not done this, but because we've taken everything apart, tramming is just part of what we're going to have to do. So I'm going to know that. And now, one other thing here, if you come close to this wrench, I'm using a ball end hex wrench. And it's actually starting to wear down. So when you're using a ball wrench, you always want to be careful, especially on the smaller bolts and a wrench, because when you're tightening things up, you can actually break that ball off into the screw head. So when I start tightening things down, I'm not going to use the ball head. I will use this side of the wrench that does not have a ball on it. Actually, I like this better. Now it's time to put this Z carriage on the machine. And for my case with the Long Mill, we're just going to drop the wheels on here. And then we have the screws that I have put in here from the old V wheels because I didn't want to lose them. And that's the best way to do it, is by putting them right back where they belong. I know exactly what holes they go into. So now I'm going to take the screw out and I'm going to assemble this. This flat washer goes on the outside of the V wheel. And we're going to get the wheel on the track. And I'm doing this by eye. We're going to push it through. The V wheel started on the track. And I'm going to put the nut on and tighten everything down. And now it's time to get the carriage assembly, the Z carriage assembly, so it is tight on the rails. And we're going to do that by adjusting the cam nuts here. So we're going to come in on the top of the long mill assembly. You can see there's a nut there, and it's got the hole that's off center. And that's because the whole nut is off center relative to the hole. And that's what we call a cam. So what that's going to do is going to enable us to tighten everything up. Let's see, that's the wrong way. There we go. And I can feel as I'm turning it, it's starting to squeeze the rail. And at that point, I'm going to hold that nut in place, and I'm going to tighten it down nice and tight on the bearing. Now we've been at this for about an hour, and the next thing we have to do is install the drag chain and the trim router, and then we have to trim the machine. However, I've done the rest of that in a separate video because that next video was installing the spindle on the machine. As I told you in the beginning of the machine, I was getting away from the trim router and going to a spindle. So what I'm going to do is link the video for this installation up here. A little flag's going to pop out, and down in the description is for that video so you can follow through with the rest of this. Now the spindle video, you can still follow along if you decide not to upgrade to a spindle, but I do recommend that you do that because spindles are designed for the CNC routers and they cut much better than the trim routers. You don't know that until you actually do the carve with it. So at this point, follow the link for that video, and it'll also pop up here on the screen somewhere at the very end of this video, and it'll be linked down in the description to do the rest of this maintenance where you're installing the drag chain and installing your trim router and tramming the machine, which is really important. Tramming is making your machine, your axis perpendicular to your work surface. If it's off like that, your cuts are going to be kind of funny. So if this video was helpful to this point and you know what to do a deep dive and a deep clean on your CNC router, please give me a thumbs up. Comment down below on anything I might have missed or some suggestions that you might have so that other people who are watching this video can read them. And go check out that next video. I'm Garrett with IDC Woodcraft, the place you get your CNC router bits from. Have a great day, better tomorrow, and happy CNCing. IDCwoodcraft.com